The internet is full of machines that promise free energy. Most of them fail for one simple reason. Nobody can show you where the energy entered. A box spins, a magnet turns, a motor runs. A wire lights a bulb, and somewhere in the middle of the demonstration, the most important question disappears. Where did the energy come from? That question destroys almost every miracle machine on the internet. But every once in a while, a machine shows up that looks like it belongs in that fake world, and then turns out to be something better. Not magic. Physics. Picture a sealed metal chamber. Inside it, a heavy rotor is spinning so fast that you do not see motion anymore. You see stored force, no flame, no fuel tank, no lithium cell stacked inside like a normal battery, no liquid electrolyte doing chemical work. Just a wheel in a controlled chamber, holding energy as motion. That sounds suspicious until you ask the right question. Did energy enter? Yes. Electricity entered first. The machine used that electricity to spin the rotor. Later, when power was needed, the spinning rotor slowed slightly, and the machine turned that motion back into electricity. That is not free energy. That is the trick. The energy changed form. My name is Max Voss, and when a machine claims to make power from nothing, I stop listening. But when a machine changes energy from one form to another, I follow the path. Because real systems always have a path. Energy enters somewhere, it changes form somewhere, it gets stored somewhere, it comes back out somewhere. If you cannot find that path, you are probably looking at a scam. But if you can find it, you may be looking at an old piece of physics that people forgot how to see. One company trying to build around this idea today is Taurus in Utah. But before the company matters, the physics has to make sense. Because the machine at the center of this story is not new in spirit. It is a flywheel. A flywheel is one of the oldest ways humans learned to smooth power. Old engines did not produce perfectly even motion. They pulsed, a piston fired, then it coasted, then it fired again. Without help, that motion would be rough, violent, and uneven. So engineers added mass. A wheel. The wheel absorbed some energy when the machine pushed hard, then gave some back when the machine weakened. It did not create energy, it smoothed energy. It caught the roughness. That is the forgotten idea hiding underneath this modern machine. A flywheel is not a fuel source. It is not a magic generator. It is a buffer. And the modern electrical grid needs buffers more than most people realize. Because the grid does not only have an energy problem, it has a reaction problem. Most people imagine electricity demand as a smooth line. A house turns on lights, a refrigerator runs, a factory uses power, a city wakes up. But real electrical systems are not smooth. A large motor starts, a compressor kicks on, a factory load jumps, a fast charger pulls hard, a data center demand changes suddenly, a voltage sag moves through a local system. A cloud passes over a solar field. The problem does not always arrive slowly. Sometimes it hits, and that is where the battery story becomes more complicated. A chemical battery can be excellent at holding energy. That needs to be said clearly. Lithium batteries are not stupid. They are not obsolete. They are one of the reasons modern energy storage works at all. They can store energy from solar, they can provide backup power, they can support the grid, they can respond quickly in many systems. This is not a story about batteries being bad. The real problem is asking one machine to do every kind of job. Sometimes you need something that carries energy for a long time. Sometimes you need something that reacts to a sudden disturbance. Those are not the same job. A battery carries the load. A flywheel catches the hit. Think of a vehicle. The fuel tank carries energy. The shock absorber handles impact. You would not ask the fuel tank to protect the wheel from a pothole. That would be the wrong machine doing the wrong job. The electrical world has the same mistake. And this is where the word storage becomes too small, because energy does not have to stay in the same form to be useful. And storage does not have to be chemical to be real. A raised weight speaks gravity. A hot tank speaks thermal storage. A compressed gas speaks pressure. A chemical cell speaks reaction. A spinning wheel speaks motion. We became so used to batteries that we started treating chemistry as the only storage language. The question was never which language is best. The question is what problem you are trying to solve. If you need hours of stored energy, use the machine that holds hours well. If you need a fast response to a sudden hit, use the machine that responds fast. If your system needs both, stop arguing and split the job. This is where the flywheel starts to make sense as a real engineering answer. Electricity enters a motor. The motor accelerates the rotor. The rotor stores energy as rotational motion. The machine tries to reduce anything that steals that motion. Air drag, friction, heat, vibration, imbalance. If air is left inside the chamber, the rotor wastes energy fighting the air. So advanced systems use sealed low-drag environments. If the rotor is poorly supported, energy disappears into contact and wear. So modern systems use carefully engineered bearing arrangements to reduce losses. If the rotor is unbalanced, the machine becomes dangerous. So precision matters. This is not a toy. A fast-spinning rotor is a disciplined argument with physics. The rotor stores motion. The chamber reduces drag. The bearings reduce contact losses. The motor generator moves energy in and out. The power electronics control the exchange. The software decides when the flywheel should respond. And the safety system respects the fact that stored motion is real energy. That is what separates real engineering from internet fantasy. A fake free energy machine pretends there are no limits. A real machine is defined by its limits. The limits tell you what the machine is for. A flywheel usually does not make sense as a giant all-night energy tank for every home. It is not automatically cheaper than batteries. It does not replace every storage system. It can lose stored energy over time. It needs precision hardware. It needs electronics. It needs a use case that actually rewards fast response, repeated cycling, and power quality. But if the problem is short, sharp, and frequent, the flywheel becomes much more interesting. Because spinning mass resists sudden change. That is the old physics. And the new grid has a new kind of sudden change, not shaking metal, electrical stress. The kind that appears when modern systems demand power in fast bursts, when renewable generation moves with weather, when buildings and equipment create sudden load changes, and when the local grid needs help before a distant power plant can respond. So the real story is not flywheel versus battery. It is flywheel beside battery, a machine for fast events, a machine for longer duration. A system that stops pretending one tool is supposed to fix every problem. That is where Taurus enters the story properly. Not as the hero of the whole energy future, but as a useful case study for this split job idea. Taurus is not interesting because it found free energy. It is interesting because it is building around job splitting. Its flywheel product called Taurus Spin is marketed for very fast, high-power events. Millisecond response, high cycling, short power-intensive work. Beside that sits the battery side of the system, designed for longer support. The flywheel handles the fast disturbance. The battery handles the longer delivery. And software decides which machine should respond. That is the important part. Not the branding, the arrangement. Because in a real system, arrangement can matter as much as the parts. Public reporting says Taurus secured $200 million from Magnetar to scale modular hybrid power systems. The company has described a large Salt Lake City manufacturing campus called Giga 1. Rocky Mountain Power and Taurus announced a commercial and industrial demand response partnership. Gardner Group agreed to a project involving nearly 26 megawatt-hours of battery and flywheel storage across commercial real estate. Those are public, checkaplex signals. None of them prove the entire future. Taurus is still early. The gap between announced partnerships and proven performance at scale is real, and it deserves watching. But they do show something important. This is not only a drawing on a whiteboard. The idea has money behind it. It has utility-facing partnerships around it. It has commercial deployment announcements tied to it. The machine is trying to leave the laboratory and enter the grid edge. And the grid edge matters. Because power problems are not always solved by building one giant thing far away. Sometimes the problem appears locally, at the building, the factory, the charger, the data center, the substation, the point where demand suddenly changes. If the disturbance enters locally, a local buffer can matter. That is the deeper shift, not a fantasy of free energy, a smarter first line of defense. Now this is where we need to be careful. Because the phrase free energy is powerful bait. It makes people imagine no bills, no fuel, no grid, no cost, no consequence. But physics does not care what people want their bills to be. Energy has to enter, losses have to be managed, hardware has to be paid for, materials have to survive, controls have to work, maintenance has to exist, safety has to be respected. A flywheel does not erase those realities, it lives inside them. So if someone tells you this kind of machine creates energy, walk away. If someone tells you it replaces every battery, walk away. If someone tells you it lasts forever with no system losses, walk away. If someone tells you it will make the grid irrelevant for every home, walk away. That is not physics. That is Carnival electricity. The real version is quieter and stronger. A flywheel stores energy that was already put in. It stores that energy mechanically. It can give energy back quickly. And when paired correctly with chemical storage, it may make the whole system behave more intelligently. That is enough. It does not need fake miracles. The same mistake happens in home cooling. People blame the air conditioner for heat that entered hours earlier through the roof, attic, walls, and glass. The AC made the noise, so the AC got the blame, but the heat had entered long before. The same thinking applies here. If a battery is sitting at the end of every electrical disturbance, it may be overworked for a problem that should have been handled earlier in the chain. Find where the problem enters, then put the right machine there. That is where money is saved. That is where machines last longer. That is where systems stop looking mysterious. The old wheel did not come back because someone found a loophole in physics. It came back because physics still has a job for it. And in a grid that increasingly needs speed as much as capacity, that old idea starts to look modern again. So no, this is not free energy. That part is fake. But the trick is real. A wheel spins in a chamber, waiting for a disturbance. A battery sits beside it, waiting for a longer job. A controller between them decides which part should act. The flywheel catches the hit. The battery carries the load. That is the whole architecture. And once you understand that, the phrase free energy changes. You stop hearing it as a promise. You start hearing it as a test. If a machine claims to make power from nowhere, ask where the energy entered. If nobody can answer, the machine is not mysterious. It is broken logic. But if the answer is clear, the path is visible. Energy entered as electricity. It became motion. It stayed as rotation. Then it returned through a generator. Now you are not looking at a miracle. You are looking at storage. The trick was never free energy. The trick was motion. Before you ask whether a machine can give you free power, ask the question that exposes every fake system and explains every real one. Where did the energy enter? What form did it take? And what problem did it solve before the expensive machine had to fight it late?